Okay, welcome to the Configuration Management Chalk Talk. And configuration management is kind of a fancy phrase for a pretty broad discipline. But really what we're talking about here is change. So let's just start off with a little bit of the Verant perspective on this before we dig into some of the more academic topics. Change is really all about going from what I've kind of personified as the cloud to the oval to the square, where is the cloud is typically, the stuff that's way out there, I guess the innovative stuff. The oval is where we're bringing it into something that is tangible but still not really defined and produced. And the square, I think, is when it becomes a production, regular routine item that is well defined and is tangible. Of course, in the software industry, even the tangible square isn't all that tangible because it's still dealing with little bits and bytes floating around. But I think if we still think of it in terms of its physicality, then this stuff becomes much simpler to understand. The change in engineering or change in the software industry or any high-tech business is not something that's negotiable. It's all a matter of how we deal with the change, because the change is both our nemesis and it is our opportunity, but at its neutral point, it just is. So I think configuration management isn't about embracing it from terms of getting an opportunity seized or to deal with just the inevitability of not having it become an anchor to us. It just deals with it straight head on and says here is a systematic way of dealing with change in an engineering environment. So it's a matter of, do you want to embrace it or do you want to go crazy by it, because it's going to be there. And even the change process is going to change. So change begets change, which begets change. So there's change everywhere in the product, in the way we deal with the product, in the way we deal with the product, the way we market. Everything about an engineering environment like this is about change. So it really comes down to, when you're dealing with a particular area, do you want to have chaos, or do you want to converge into something that becomes more standardized but does not try to shoehorn and fit square pegs into round holes and things like that? It just isn't going to work. That is fighting the change. So the convergence means that we're going to get better and better at dealing with certain aspects of change, but we're always going to have new challenges and new ways of changing things. And it's a matter of, are we going to find a way to deal with that change in a systematic, not a structured or a canned way, but a systematic way, so that it doesn't have to become chaos. But chaos is not necessarily a bad thing. It's something actually that brings about innovation. So we have to be careful that we don't assume that chaos or something of that nature is bad. It just simply needs to be converged, all right? So if you look at a little disclaimer here for Verant, and this is, I think, where I still have a little trouble making sure, or feeling like I'm on the same side of the table as everybody else. Way back when, 5 years ago, we were going to learn a bunch of disciplines like configuration management, software engineering, theory of constraints, things like that. And then we had these projects that were out there that are various levels of documentation. Some of them are incredibly intricate, and other ones have nothing, and then there's all in between. So the idea was that we were going to try to bring some rhyme or reason and a fresh perspective of how to manage these projects by going back and essentially like trust built and exemplars and so on, and kind of repositioning them to take advantage of some of these disciplines. And then certainly all new projects would be the new way. But we also said for 6 months in there, we weren't going to just do this, but essentially the dedicated purpose of Verant for that 6-month period was just to sort all this out. And take on projects, take on new product development, and so on. But really, it was all about finding a new way to do that. And we really have not done that. We've done it in bits and dribbles. But for the most part, we have this Verant today that is what it is. I had a vision for what Verant tomorrow will look like, and that's something I have to let go of. But there are different parts of this Verant tomorrow. There's those things that or my mindset. Maybe they don't have to be there. There's different ways of doing it, all different sorts of things. But what can't be dismissed is that there are gaps between what we're doing today and what reality is presenting to us. And that is essentially, we have all the challenges of a big software company. We could just as well be a 50-person company as a 5-person company. Because we still have to adopt standards and we still have to find a better way to do configuration management than you would if you were a one-person company or if you were developing something like snowplows or something of that nature that doesn't have a lot of configuration management type things in it. We'll hear more about that in a second. So essentially, we have to develop systems that are just as sophisticated as the big companies, but they need to be scaled down to suit our size. And that's tricky because had it been easy, it would already have been done. I have to keep emphasizing that, I guess. So I know what needs to be done. I'm pretty clear on that. And I know that I have not been successful in the past in scaling it down and making it practical. And part of that, I think, is just a matter of resources. And another part of that is, maybe my vision of tomorrow wasn't really realistic. But we have to sort that out. So I guess the disclaimer here is there is no way to close this gap by me delivering a sugar cookie or something and just saying that I'm going to somehow make up this gap. It doesn't matter how it happened. We simply have to not continue to deny or take this linearly in the sense that we're going to have the Varant today versus what reality presents us for configuration management challenges. They have to all be taken at once. And when we go through this stuff, you're going to see there's a lot of things that we just need to shore up, but you can't shore them up one by one. We're just going to have to find a way to get ahead of the curve. And so that's the disclaimer, and that is, I think, both an opportunity and a frustration on my part, because this is not terribly complicated in terms of what we have to do, but it is a bit overwhelming, I guess. And if we get overwhelmed by it, then we're going to make it complicated. So let's just dig right in here and say that configuration management is really 4 separate disciplines. And it's about control, planning, status accounting, and identification. Okay? Now, what is configuration management? We haven't really defined that yet, so let's try to go right back to that fundamental. It's the systematic approach to planning, identify, here's the same 4 words again, a systematic way to plan, identify, control, and account for the status of a product's configuration from its inception through its whole intended life. So a configuration is the bill of material, or all the things that go into it. So if we were building a snowplow, it would be all the brackets and assemblies, the documentation, everything about that, and it would be a matter of tracking the revisions, how we identify things, and how it has evolved over the entire life of that product. So as new versions come out, as it gets replaced by newer and upgraded versions and so on, you end up with this product life cycle. Sometimes this is called PLM, product life cycle management, where you go from initiating something, and if you've seen the innovation chalk talk, this is even before that stage. And then it goes from innovation to development to deploy to support, and of course this repeats itself around and around as new versions come out. But then eventually it gets decommissioned, or in the software industry we typically call that deprecate, where it's still being used, but it's no longer being supported. Whereas the support continues out here for for other purposes of referring them to other product lines or what have you, but the product actually falls down here into a deprecate mode and eventually into an obsolete or retirement mode. So this is the product life cycle, and configuration management is what ties all this together. However, because this is such a broad topic, I'm really going to define product management as that life cycle development. We're going to break that off into a separate chalk talk where we talk more about how you go about managing like the roadmap and so on, and how you go about rolling out a product in context of other products that we're currently supporting. So we're going to keep that as a separate topic and just focus on the 4 central areas of configuration management, and really we're going to focus mostly on the control area because the other areas get to be a little bit engineering related. So let's dig into some definitions. We have an engineering document, and everything here is going to be referred to as engineering, but that's the same thing as, or just put it in terms of software. Is going to be a drawing, a specification, a process, artwork, parts list, bill of material, or other document which is used to produce, in this case, software. So virtually anything we've talked about in terms of artifacts, what have you, is an engineering document from a configuration management standpoint. A controlled engineering document is where we have the defining moment. You'll often hear me talk about something, whether it should be in a repository or not. Like working documents versus something in a repository is all the difference in the world to me, because one is controlled and one is not. And it may start in working documents as a non-controlled, but once it goes into control, there is no going backward. And I think it's important to identify which things we're producing are controlled and which ones are not, and then just get on with the control part of it, because the advantage of control is that we assign revisions to it and we have a formal control over it. And in theory, it's supposed to liberate this process, not encumber it, because it keeps a structure into something that is constantly changing and doesn't force the person who's writing this stuff to constantly keep track of what they're doing and what it means and where it's at, because there's a system to do that for them. So engineering documentation control is also a phrase used, but it's the same as configuration management. So a lot of this is about documentation, and we have to be a little careful, because sometimes it's perceived that documentation is really the end result here, and it's not. Documentation is the broadest sense in that it's all of the information needed to produce what we're doing, the development and the production of software. The documentation literally, I think, has to serve a specific purpose and may not be as comprehensive as tradition would have it. It only has to serve the purpose for what it's intended at that time. So a lot of our stuff is only going to be as good as needed to get the code written, and it will probably never get finished. And that is a real tough one for me to swallow, because you're used to then going back after you've done it and get this documentation just perfected. But the bottom line is nobody ever reads it, and it becomes more of an encumbrance than it does a benefit down the road. Okay, so configuration management, I think we just talked about that. A configuration is a technical description and arrangement of parts or assemblies into fulfilling form, fit, or function of a functional requirement. So for us, that would be parts and assemblies. We have kind of grappled with this, if it's a module, if it's a component, if it's a system, those kinds of things. The same analogy goes, though. If you're developing a system, then it contains a bunch of components or modules, and that is a bill of material, an indented structure. The whole point, though, is it's to fulfill some requirement that is being called out in a functional spec, or in our case, a SAL probably. All right, so why do we do configuration management? Because there's a lot of technical complexity of things. We may have something as simple as a WinBatch program that goes out and automates something. We compile it, and it's one executable. Well, there's a couple of DLLs that go along with that, and then there's the source code that came from, and then there's the version of WinBatch that produced that, which also has to be part of the documentation, since we have to know which version with its limitations was used to compile that, and then we have to know the operating system, the environment it goes into, the version of Visual, the version of SQL, it goes on and on and on. So all of a sudden, something that seems very simple gets to be enormously complex if we ignore some of that complexity. So this goes back to the KISS principle, which I just really don't like. I think things need to be as complex as they need to be, and no more. But when we try to put our head in the sand and make things overly simple by ignoring things that are just annoying, like the situation, the environment, those types of things that are tangential to the thing we're actually working on, that's the gotcha point, because those are the things that are not that difficult to capture at the time, but they are virtually impossible to figure out down the road. It's like trying to reproduce a crime scene with no pictures or anything of anything. All you have is just the object of investigation. Now you're relying on people's memory and going back into time, and that's exactly what Verant does. And as opposed to capturing information up front that is relevant and in a systematic way, we don't necessarily know what's relevant right away. So that's where the continuous improvement comes in. But we don't have to make the documentation of the environment and the surrounding conditions as comprehensive as everything that is there, or we'd be documenting the whole world. So I think that's where some prudence comes in terms of balancing things, and sometimes it's as simple as just taking inventory or a snapshot of that environment. Physically, that would be like taking pictures literally of a crime scene, but in our case it would be something like just getting a printout of what's in memory. Maybe all the DLLs that are loaded in memory, just dump that out, or maybe just dump out the configuration of WinBatch if that's the compiler we're using, and just have it dump out the about box or something that says here's the version of it, the patch level, all that kind of stuff, and just get a screenshot of it. Something like that, at least to get us started, would be adequate for some of those purposes until we really understand what it is that we need. But I think we're way beyond that, personally. I think we know what we need. We just need to have a systematic way of gathering that's applicable for whatever it is that we're doing. Okay, so we're going to get to that in a second here, why we have different rules of change depending on what we're doing. And trying to have one uniform set of change rules really makes life difficult for everybody. It is not something to simplify life, okay? So the configuration management objectives are to plan, identify, control, and account, like we said, achieve logistics support at lowest life cycle cost. So that's a point I think we often lose, is that this is not just busy work. This is not just infrastructure. If it is, then we shouldn't be doing it. But if we're encountering situations where we are unable to get our job done, we're not able to do the direct task asked, and it starts degrading into infrastructure questions, then there is no other explanation other than that we cut short on that and we need to do something about it. And I just don't understand why there can be debate there. I think the healthy debate is how far do you go with it and what are those consequences? And when we come across consequences, then we need to understand what to do different. But it's not to stifle creativity. The whole point of this is to make people more creative. If you're having the person who is innovating and writing software or designing something is constantly being distracted by having to produce documentation and file things and name things and categorize things, you're missing the point, because that is stifling creativity enormously. An efficient change control process is something that is limber and is an engine, is available and is intuitive and has a uniform use of procedures based on what activity we're doing. And that is the point I was just making about there has to be different change procedures depending on the activity. There's just no getting around that, because Vaurant is essentially a big company. We have all the phases of software development and all the hassles of supporting and innovation and all that kind of stuff, which have different rules. Okay, so this is just another representation of the 4 areas of configuration management. Just to drive that point home. Okay, so what is a configuration? What is a product? Well, I guess this is pretty silly, but we'll do it anyway. A product is anything offered for sale. Okay, so there you go. For us, that would also be a service. The product life cycle here is a little bit more comprehensive drawing of what's involved in a product life cycle. I'm not going to go through all this, but if you look at our conceptual through development, through design, through production, this is how configuration management sees that. Now, these handouts, by the way, are taken from a class I took, I think it's almost 20 years ago, and it's all about hardware engineering, very little mention of software. But you'll notice that it still has the same phases in here, which I find quite interesting. Production would be the same thing as our development, and their development is the same thing as our design development. So kind of a wording little confusion here, but they get into here where we're specifying the product, and then as we've talked about in the innovation study, or Chalk Talk, that we have some pre-production or pre-release 1.0 prototyping and feasibility stuff that goes on, but that also has to be coordinated by configuration management, but just not at nearly the level of discipline that it does over here. So it's a matter of graduation in terms of amount of control, and that's the beauty of configuration management, is it gets started way back here, but it only gets involved to the degree where it's helping each phase. So by the time it gets over to here, we already have a structured approach, and when it's handed off to the 1.0 where we're trying to sell to the marketplace and so on, we're not trying to hand off something that is just freshly out of the clouds. It's been in this phase for quite a while, so it's going to be over here and very well defined. And I think that that's why things like Take-Two have worked well for us, because we were already over into here to begin with. We might have thought we were over here, but we really weren't. We had gone through all this very difficult feasibility, innovation, conceptualization, and so on a couple, years ago. And like the dictionaries, we're clearly way over here, to the point where it's really too far over here. It's working against us, that we can't even get something innovated into it. We finally did the PDF, but we haven't made any changes, substantial content changes to the dictionary for years, and that's a shame, because to me it seems that trying to introduce something is so foreign over here to something that is so well defined that it's just inconceivable that it could ever get done, and that's just has got to change. So in this case, like I say, it's too far along. But anyway, here we go. That's what the life cycle looks like, and what we're going to do now is look at all what's involved with configuration management through the 4 different chunks of configuration management and the life cycle. We're not going to do all of these, but we touch on almost everything because of the nature of our business. So here it is, the identification, counting those different categories, and this was actually broken down here. But you get into, for identification, like how do you identify your products, part numbering, serialization, how do you identify your changes, in other words, revision control, rev numbers, how do you identify your specifications? I don't think we do. We just say design spec, but they really do need to have some kind of unique identification to them and a revision control. Configuration, identification, documentation, that gets into what I was just kind of broaching on, is that the documentation, the bills of material, in other words, how the software is put together, the DLLs feed into the executables, feed into an overall systems part. For example, like integration for TrustBuilt would have multiple executables and things under it, but the overall integration project should be identified as an ID with a revision. Your product support manuals, all this kind of thing goes in there in terms of how that is identified from a documentation or metadata. For us, a lot of this is metadata out in SharePoint, which makes things even more elusive, but nonetheless, it's still there. The other part of that is the requirements, like the version of Visual, the Gupta runtimes, those kinds of things are all implied by that. Okay, the product configuration itself is the bill of material and the parts list. For us, we have 2 of those. We have a logical and a physical. The physical is what I've just been talking about, where you have the DLLs, you have like INI files, executable files, all the things that are required to deploy, let's say, an integration project. But the logical bill of material is what Andrew and I typically work with, and that would be the libraries and things that are associated with the source code that are required to build it, but are not necessarily physical, or at least don't have the same boundaries. So, and that's where it gets to be a little elusive, but it's just saying that, if you have, let's say, a hardware example where you're building a photocopier and you're looking for you have circuit boards and you have mechanical parts that are all part of the physical indented bill of material structure. But on a particular circuit board, you may have multiple functions that are being done, logical functions. For example, it may rasterize, or it may, capture the image, or whatever the heck goes on those things. But those may all those functions may be taking place in one physical circuit board with one part number, but logically there are multiple things taking place in there, and some of those logical functions may cut across other physical parts like rollers and sensors and things like that. So you end up with a logical structure saying, for this feature, for this function, here's all the things we need, all the components. But that doesn't line up with necessarily the physicality of how it's put together in the assembly line. All of that comes into play, though. Typically all you see is the bill of material of the physical, but the most helpful part in terms of engineering is that logical structure, and it's really no different for us than it is for hardware if you look at it using that example I just gave you. Okay, then over here we get into the controlling part, and this is really beyond Verant right now. We're going to be able to punt on this for a while, but essentially this is the engineering change control, field change control, a formal process of filling out paperwork and formalizing the advancement between releases. And we're going to talk about that towards the tail end because the concepts are very important, but the formality of it can remain, informal, if you will, at least for a couple more years, I think. But it's important to understand the concepts, so hang in there with me. All right. Here's kind of beating the same point again, but configuration identification is the documentation which is a properly identified and defines the approved configuration of products under, well, at least for sure in production, but most likely also those that are being designed and tested before it goes out to the field. Okay, the defining moment is once something hits a customer, no matter if it's test software, full release software, beta software, whatever you want to call it. If a customer ever lays their hands on it, then it must be under control of the configuration management system and must have a revision from that point forward, and there are no exceptions. This is a very rigid system on some points and very flexible on others, but that's one of the points that's very rigid. No matter what you do, you typically want to start assigning revisions but well before it gets to a customer, but you must do it at that point because you need to know what a customer has without asking that customer to tell you what they have. So all this is a formal thing that's been approved. So if we send a beta version of integration software out to TrustBuild, it should have an identification number on it with the revision, and underneath that should be all of the approved components and documentation, everything else that was required to build that, including like the version of compiler we used, the version of Visual, the test database that we were using, all the stuff that we care about that they don't care about. But it's still part of that, and that all has to be approved, or in other words, it's all orchestrated underneath that one number and approved, at least to the extent that that's what was captured. Okay, it doesn't mean it has to work. It doesn't mean that this is the end all, but the configuration management discipline, that system has said, we've gotten a snapshot of it, so when we say they have the integration software 117 revision A, then we know that these components are what shipped along with that. That's what the approved means. So it's just that simple. And we don't really have to get into the technical details or even have knowledge of the technical details to be able to capture that information. It's a librarian function, it's a control function, and it's best dealt with that way. Otherwise, it becomes controlling if it's incumbent upon the people doing the technical work to have to explain or have everybody on the same page. It becomes this beast. So I think this is where we have to have boundaries, where the discipline of control is to control the documentation and information about what we released, and then the job of the people who are releasing the software is to have it function according to what it's supposed to, but they have to follow the rules of configuration management, but they are not there to enforce them or to understand them necessarily, or to have to do this crossover and justification, which should not be a competing thing. They are complementary disciplines. And I think that that's been a bit of a challenge for Verant because just things tend to be a bit chaotic still, and therefore we're trying to help each other a lot, but really this is more about boundaries than it is trying to be helpful to each other. Okay, let us move on to identification numbers. All right, I'm just going to put this in there because we're talking about part inquiry lately, and I just thought this might be interesting. But significant or non-significant numbers which identify a specific product are usually assigned by the, I believe it or not, marketing sales organization, and this is a big long section, but we'll just keep it real short here. Not serial numbers. Got the wrong page. Here we go. Part and document numbers. The system, significant or non-significant, and there's a whole section here. I guess I'm going to kind of skip over this, but they really do emphasize the fact that having the non-significant numbering system is really the way to go. And it's interesting how this ties into what we're trying to sell to our own customers. You will see as we get into this, having significant numbers really makes configuration management unnecessarily complicated and infers meaning where there's not meaning, and when there's not readily available meaning, then people work really hard trying to get meaning out of something that has no meaning. So in this case, it is just a counter. So the more insignificant, non-significant we make some of this stuff, then it stays that way. It doesn't matter if we go from B to C what we're talking about, because we're going from B to C. That's it. And if we try to imply something by saying, well, the B to C means that we're doing something that is a major change versus a minor change, and all of a sudden you're going to want to have it, somebody tell you, well, why is it major, not minor? And we get into all this stuff that is just not necessary and is counterproductive. And that's kind of one of the selling points that we really need to push to our customers, that why do they want these damn significant numbers? And they better have some really good reasons for it, because most likely their pains are coming from that decision and not from the software itself. And we have to reveal that, I think, for them to be able to make use of like a part inquiry. Okay, so I digress a little bit. Let us continue with the bill of material. I think we've kind of talked about this as well. There seems to be a lot of redundancy here. The complete listing of everything goes into there. A bill of material is nothing more than your shopping list you take to Menards. In the case of visual, just so you realize that that's a bill of manufacturing, which includes operations in addition to materials. So it's a little bit different. There's typically a router. Router tells you, all the different steps are needed to build the thing, like labor and welding and sawing and punching. And the bill of material is the parts. But visual combines it into a bill of manufacturing. And what we're talking about here, though, is strictly the bill of material or parts list of what goes into something. However, it is interesting to note that we do capture some of the verbs there of how we do things, but we do it by capturing the version or the status of that. So, for example, Andrew builds code. We don't say, the operation is a compiler to turn source code into an executable, but we do have both the source code and the executable under revision control and identification. And then the way to handle that, the action stage or that verb, the compiler, is to just simply identify which compiler, which software was used, which revision, and anything else that would be out of the ordinary for us to know. So we've kind of talked about that before, but in a sense, that is the complete prescription, the complete procedure for how to build something from a manufacturing standpoint applied to software. Now, where do we stick that information? I'm not quite sure. So that's going to be some of the challenges, but if we don't capture that, it's going to come back to haunt us, and it has come back to haunt us over and over again. So the question becomes, do we want to just avoid the whole thing about capturing like which tools were used to build something? Do we want to rely on me to remember that stuff? Do we want to figure it out by reverse engineering and happenstance down the road? What do we want to do about it? Because the lack of understanding that and making a decision about that is not going to make it go away. It's going to make it come back and rear its ugly head in a most ugly way that won't even probably look like that kind of a problem. But guess what? When you're having really elusive problems of reproducing bugs and things like that, or you're having things not compile or not interoperate correctly, or things not playing well, it's most likely those tangential things that are causing the problem, not the head-on direct thing we're working on. It's going to probably be because of a decision long ago. So that's where we need to all be on the same side of the table and start realizing that that's where we are, and we need to find a quick but reasonable way out of this that's going to document this complexity. So let's look at models of product. And this is overkill because this is coming from the hardware industry, but you have your breadboard model, which is a very early stage. We have a prototype, and that would be our feasibility or our proof of concept, things that we're going to start doing for our new product development. And then we have pre-production, which I believe we call beta software or even alpha software. And that's something where a customer may have their hands on it, and we're trying to get it tested and so on. And then the production model is really the formality, and it might be as simple as having the last pre-production model just be renumbered to be the production, and I think that happens quite a bit. We just don't do the renumbering, unfortunately. Okay, now let's combine those models with what releases are. And a release is whenever we are formally putting something out and putting revision control on it. We have engineering release, which is we're doing a very limited procurement of parts. Well, we don't buy parts, but in other words, we're doing something that is still a breadboard or a prototype or feasibility. So we may be using, if we're doing crystal reports, we may be using a trial version of the software. We don't even have this. We don't even own the software yet because it's very early on. It's just something that we're doing in the creative mode. Interesting, I had that in there. Didn't even realize that. And then we go into the pre-release, which is after the innovation stage, where we're actually getting ready to do this thing and we're testing it and so on. And then the formal release. So these kind of line up to what I just said before. Like I was mentioning, that sometimes that last production release is nothing more than a formality, and I think that is often the case in software. So this chart here attempts to line these guys up, and it's a little goofy, but let's give it a whirl here, where we have things divided into classes of change. They do it A, B, C. So starting at the bottom, a Class C change is that engineering release. That's when we're doing something as a prototype, we're doing breadboarding, we're doing feasibility studies, so on like that. So that's going to be over here. And then the pre-release is Class B and the full release is Class A. So we're going to start referring to things as Class C, B, and A because that's the way the industry does it, and it gets us out of this semantic game of what do you call things. And you end up with developing and developing and developing. We use that word so much that this makes it very clear. So Class C is very early stuff. And that would be things that I'm typically doing, or I ask somebody to go out and do a test drive and so on. This is not under ECO control. In other words, engineering change orders. It's not even part of configuration management per se, because the changes are not going to be controlled by configuration management people. It is, though, going to have a very informal revision control, and that would be just using a date is what most people recommend. So if you're doing something, just date it so that when you come back to it, you know which one you've got. And it's just that simple. But it doesn't go into any kind of log. It doesn't go into any kind of formality. There's no documentation other than the thing that you're working on. We just recommend that you date things and that you know that when something is dated and has no other revision control markings on it, then it's engineering release or Class C, which means it is nowhere near this. It's still over here, okay? And we can't make it to be something, if you try to send that to a customer, I mean, that's so far beyond, it's jumping way up here. So you're not to be doing things like that. We can't misrepresent it. So Class B is something where we put it under change control, but it's going to be numbered for revisions. So it's going to go 01, 02, 03, 04 for each revision. And it does go into some kind of history log, but it is under a very informal process in the sense that it doesn't go through a change control. We're not going to be doing change control processes for a couple of years yet, so that is kind of a moot point as we get up to Class A, because Class A would go under a formal revision control. In other words, you'd have a change control board actually monitor and regulate how these changes get folded together or rolled out into the field in a controlled and disciplined way, especially when you have an installed base and need to go out there and get patches and things to them. That would be done in a controlled way. But the Class A releases are identified by A, B, C, D, alpha letters, and indicate that this is something that is a regular production item. So, for example, part inquiry right now would be going to Class B as we get ready to take it to the first test customers. Something like the dictionaries and vLauncher are at Class A. The new release of vLauncher would be very briefly at Class B, but it would jump right up to Class A almost immediately because it's a mature product that's just being improved upon. Okay, so for us, it's kind of, these are about the same. Really what we have is Class A and Class C. The Class C is the stuff in the clouds. The Class A stuff, that's the rectangular, well-formed stuff. And in between is where I think the jury is not in yet in terms of if there's going to be a benefit of formalizing some of that. And that's, I think, part of my challenge is can we go right from here to here without something intermediate, and I'm not so sure we can do that, but we'll see. All right. Oh, I do have a little comment here from 20 years ago. Never refer to documents with anyone by saying that drawing. If Class C, note the date on it, then you can refer to it as the drawing noted with the following date. So otherwise, everything else has revisions on it, so you have some way to identify it instead of using the word that drawing. Okay. Whew. Some of the stuff is like really pounding home the same old points. Ground rules for release. All critical components in a product shall be qualified before formal release. The critical component is the key there, and I think moderation and common sense comes to play. It doesn't mean we have to do everything. We do have brains. We do have the ability to figure things out, and there is a certain ability to say that if we have to, do some reverse engineering or whatever to avoid an inordinate amount of work in a rare situation, then we've got to make those calls, because otherwise we're going to end up with a product structure and a cost structure that we're not going to even be able to survive. Because remember, we're a small company that has big company needs, so we have to be able to balance these things. There has to be bang for the buck on all of this stuff. All right. Blah, 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 blah. No document is to be released unless all supporting and associated documents are also released. See, now this is where we're going to have problems, because this is the formality of configuration management, which is running against Agile. And here we have to be careful that we don't throw out either discipline, because they're both valid. They're not saying here that every document that could be conceived of and was used to produce the software needs to be finished and released before we can release the software. It's really not saying that. It's saying that it needs to be released at the time, those documents need to be released at the same time as the product. But if a design document is only as mature as it was needed to be and is not fleshed out in all detail, let's say it specifies the database schema and it doesn't reflect the very latest database schema, and its purpose is just as a design document, not as a formal documentation of the schema, because that is contained in the script that is releasing with the software, so it is self-documenting. If it was done correctly and well commented, then that document should be identified as a engineering release document, and its purpose has been served. It does not live on with the product. So that's really what they're inferring here, is to say that you have to draw that line. So either that document needs to be finished as a living document, or it needs to be put in its place that it was an engineering, and it doesn't need to be finished, nor shall it be finished, and it does not represent the final schema. That's a very important point to note. Quite often it's what we don't have or what we want to get rid of that helps document something. That way we're not grabbing that thing and thinking there's something there that we're missing. When we go to troubleshoot this thing years later, we'll clearly know that that was just a transient document, but it doesn't mean it should be destroyed either. I don't know that we really want to destroy anything that was used to design the product. Okay, I don't know if that makes sense, but that's really what we're talking about here. So Agile says documents only need to be as good as they need to be, and they only need to serve the purpose for which they are still serving a purpose. So once they're no longer being useful, then they need to be terminated. And but we're just saying we have to do control around that from this discipline. This discipline is not talking about content. Let's not make configuration management into the postal effect here, where all of a sudden, because we have authority and power, that we need to have it all embracing and all encompassing, saying that it's up to us to figure out that if you've written your document correctly and so on. That is not what it's about. Okay, it's really asking, does this document live on with the product or not? Those are the two choices, and if the software person has some other answer or something in between, then that's something that's not acceptable. But they don't have to justify it or explain it to the person. They just have to be able to make a choice, because it can't both live on and not be up to date. That's what kills us. Okay. So on and so on and so on. So, oh boy, we have another chart to formally drive this point home. So there's the different changes. As we're moving across these prototypes into pre-production, are kind of essentially alpha, beta, what we call in the software industry, and then production release, which is like a gold standard, I believe is another name for that. It's the Class C, Class B, Class A. We've talked about that. The formal release over here is really nothing more than saying we need to bump the revision for purposes of saying that this is the final formal release. I think for us that just pushes it over to the Class A. We just probably need to keep it that simple. But this is what happens. Like a TrustBuilt, we'll have 4, 5, 6 different releases where we're doing not prototyping. We're actually going to start testing software, and they're going to do extensive testing on it to see if it works. And one of those sticks, where they want to go ahead and go live on it. They're doing it, with caution, because they're not absolutely certain this thing is going to work. And then they go live, and then maybe we do one more bug fix or something, because there's some little thing they didn't quite figure out. But we're still at a 05, 06, 07, a numbered release, and one of them just sticks. it should go to A, because A is now saying that that's what the formal system is, and next change to that is going to be way down the road because of either a bug that's discovered or an enhancement that's required, and usually quite a bit of time will elapse there. The problem is you don't want to re-release the software just to change the revision. It's a real pain. But yet, if it still says 0.8 beta on it, which it often does, then you got to wonder, did we ever formalize this thing, or is that the latest, or did they not deploy 0.9, or what's going on? Then you have to go back and look at your records. So I suppose you can go back and just say that as of 0.8 that was the formal release, but it's a whole lot better to have that alpha not only on the component parts and the parent part, but all the way down into every piece that you distributed, which means you got to re-release everything just for purposes of getting everything to a -A. And we really don't want to do that, because I think that introduces variability into the deployment right at a time when they've gone live, which is horrible. If we give them something and it deploys wrong, and all we did is change the revision, and they crashed their system or something. So how do we deal with that? I don't know. We're going to let Mike kind of sort that out, but it might be as simple as just changing that revision or capturing the numeric pre-release class B. I don't know, but we got to do something about that, because it should be intuitively clear that when you come across any component that's in production at a customer, that you're not encountering a class B or class C, heaven forbid, because a class C should never ever be at a customer. But a class B should never be in production either. And if you're looking at a trigger and it's 0.7 or something, that's scary if they have been using the software for a while, because we don't know at that point if they really had deployed the final version of the software. And then you're into that coordination game. Well, does that one go with 0.3 of the other thing and 0.2 of the other one? It's far easier to say -A across the board is the release. And it would be very clear then that you've got all A's, and maybe if something is a B, then there would be a note in that component saying what took it from an A to a B. And everything else, all the 0 stuff, would be purged out of there because it's irrelevant at this point. So you have a very clean deployment that becomes self-intuitive if things are reasonably coordinated, because you would see that. You don't know if there perhaps is a C revision on that component, which you could then check into, but that should be in the manifest that came with the deployment, which would show you, the revision history, essentially what all the components were, that bill of material structure that has revisions on each of the individual lines. That really does belong with the deployment. I think we stopped doing that quite a few years ago, and we don't even have it anywhere right now, but it does need to go somewhere. But just as a point of reference, there can only be one record, one record keeper. We can't have it both in the deployment and in SharePoint and somewhere else and have them all authoritative, because there's just no way we can count on that. So the best thing to do is have it part of your manifest that goes with the software, unless we have a formal configuration management control process, an ECO process, which is where you would record then that master indented revision thing in the Office as metadata. But that gets to be, I think, a little bit too big for rant. But those are decisions that we can make as a team. All right, moving on. So here's the little bit that the discipline, if you learn this at like a university or something about configuration management, they don't have a lot to say about software, but they say just do it like hardware and everything will be fine. And their thing down here is fundamentally, is software an art form or is it a science? Well, not to confuse them, but it's both. But for purposes of configuration management, we need to make it a science. This is where, again, we have transitioned all the way over here to this part, and this part has different change control rules than it does over here. And I think we're starting to reveal some of that. This is Class C, this is Class B, Class A. If you want to know where these these objects came from in my own mind, that's where they came from years and years ago. This has a very formal, rigid change control process. This one has a fairly informal, but there are rules. It's just very flexible, and there's very little over there. There's just guidelines for self-infliction, but there's no control component to it. If you're trying to do this over there or this over there in terms of the applicability of the rules, No wonder you're confused, because there's no way you're going to put a formal process into somebody's thinking process in doodle diagrams of revision control. That's crazy. But you're also not going to be able to say, I'm going to deploy something out that has maybe 100 components to it to a customer that has all sorts of interdependencies to software operating systems and their environment and what we're integrating into, and control that by something as elusive as a chicken scratch date, saying, oh, that's the one we did on Thursday morning the 5th. You know, and 3 years later, you want to know what that means in terms of them upgrading their operating system. That's crazy. So that's what we're doing, folks, is we're interchanging rules of configuration management and change control between engineering classes C, B, and A. But how do you say that without having had this little lecture, because that sounds even goofier, I think. Engineering class C, B, and A, but that's what it comes down to. All right. I don't even know if I should show this one, but here is their view in configuration management of documentation, the structure. But notice how it's kind of the same thing that we're talking about. We have, this is for software documentation, by the way. You have the system, which is including like the network, and then down to PCs, and then the software itself, and then the hardware. And they're referring to the holistic system in total. So this is, I'll give you the wording that they have down here. Or at least my notes. The object file, the linkers, and everything needed to produce the product. In other words, the toolings from a hardware standpoint, or compilers. But I don't know that we even do much linking anymore or have object files, symbol libraries, and you know, things like that. But I guess Andrew can answer that. Okay, moving along. Configuration control. We're going to breeze through this one fairly quickly, but a systematic method for identifying, controlling, and accounting for the status of changes that affect the configuration of a product. Okay, now this is done, I think, fairly informally at Varanth, but it's really where you are looking to bring about a change, and this is for something, for the most part, that is already out in the field and is in Class A. So let's say we're going to change something at SIT-ON-IT or at TrustBuilt. They want to upgrade their visual software, or they want a new feature, something like that. So we're going to bring about a change. So you go through an evaluation process, and then it becomes a coordination issue, how you're going to coordinate what you're going to change, and then going through an approval process so that those changes are going to have a good chance of being deployed with success, okay? And then once you've approved it, then we go through implementation and tracking. But part of that is going through a peer review and a change control board, which we don't really call it that, but we need to start having a formalized process that we round the wagons and say, okay, here's what we're going to make a change to, here's what we're proposing the change is going to be. Out of the 50 components, we have to change 3 store procedures and 2 other things. But at that point, we need to look at the inventory of what all is currently under change control, and that's where like an Eric will come in and say, well, according to this, we have a user manual, deployment instructions, and a manifest. So what do you guys want to do with that? Are those part of this change or not? And we'd say, yep, those all 3 need to be part of this change, so therefore they are now under change control. Somebody may say, well, we have this design spec over here, we got to do something with that. And Eric will say, I don't see that under my configuration management. That must have been under you know, Class C, where it's not formally tracked. Then we have to make a decision. Do you want, I mean, if you're going to change it, then do you want to keep it under Class C, or do you want to move it into the formal structure? And I think that's a group decision where you have to decide if there's any benefit. If we're going to just revise the document because it's needed for Andrew to do the coding, then you know, we should do that. We don't have to revise the document, though. That's where we have to be careful. We can just mark it up, give it to him, and we're done. Maybe put the date on it would be nice, so we know it and then preserve it. But if we think the actual document has value, then it needs to either be brought into the system or not. But if it gets brought into the system, then it needs to follow the rules of the configuration management system, which is that it has to have revision control and be part of that overall hierarchy, that overall structure. But it doesn't necessarily have to be brought up to the level where everything in there is consistent with the way things are currently operating. That's the challenge for Varanton right there, because if we don't do that, there's a lot of implications by putting under revision control. So really the best thing to do is either get it up to speed all the way through, or just pull out the sections you're going to use to instruct Andrew, and then have that subset be under control, or just, like I said earlier, keep it under engineering control, Class C, and just note that that's the section that we used, date it, and leave it out of the configuration management territory. The downside of that is that most likely that document is going to go bye-bye. So if there's value in it today, why wouldn't there be some value in at least that section tomorrow? And if we don't formalize it, there's no reason it's going to survive. It's just going to end up in a folder in somebody's desk, and then it will surface, and we're not going to wonder, and we're going to wonder what the heck it is. So it kind of has negative value at that point, because either it's going to be lost and we're going to find it after we needed it, or when we do find it, we're not going to know if it's relevant or not, and we're going to kill a lot of time trying to figure that out. So in any event, we've avoided 10 minutes of work by not putting it under revision control, but we've created 10 hours of work down the road of ambiguousness or lost opportunities. So those are the trade-offs, and I think the decision point is right then and there. And configuration management is pretty clear. If there's a value in it, then put it under revision control. The compromise is, like I said, to do only the part that is necessary. So that is the balancing of the formality of configuration management and the limberness and informality of Agile. However, Agile is really not informal. I shouldn't say that. It just is very practical. Okay. Change. Any modification to a product. This is very rigid in the configuration management. This is one of those rules that is not up for negotiation. Any change to a product which is necessary to make the product meet the form, fit, or function of the functional specification, or to meet safety standards or reduce manufacturing maintenance costs is a change. So if you change a spelling of something in a document because it was spelled wrong, that would be about the only types of exception that does not require a formal change. That would be something that can be handled fairly informally, but even that, if it goes into a book that's being printed by a printer, then that argument goes out the door. So there are not a lot of things that can happen to a product that's out in Class A revision control that doesn't require the formality of a revision control. Okay, managing change, you have to have positive identification of the requirements, strict control of changes, who authorized it, Incorporation, by the way, let's define that word. Incorporation means that you are using something in something else. You've incorporated it. So if I have a change where I'm going to start sanding the edges of a piece of metal after I've punched them, we're proposing that. We may try it on some test cases and so on, but at some point we're going to incorporate that change into the formal manufacturing process, and that will be done as of a certain date, as of a certain revision, and if you're serializing, as of a certain serial number. So an incorporated change means that you've actually done it and brought it about, and you're not just proposing it. So that word is used a lot. Okay. We are now getting into the formality of change control itself, which I said we're not going to do. So in the spirit of showing you what we're not going to do, I'm going to show you what we're not going to do. Engineering change order is that document, and this is called an ECN, by the way, in Visual, which is a really bad name because an engineering change notice makes it sound like it's a weather forecast that you can take note of. It's not. It's an order. This is a directive. This is not a notice or a memo. This is a directive. So engineering change order is really the thing. That would be like saying, a judge issues a notice when they want to, when they're issuing an order. This is not something that's debated. So this is what an engineering change order looks like. We essentially do this, but we do it informally, and the part that we can't keep informal is the identification of it, and that is the revision control. We do a pretty good job at that, but it tends to be just Andrew and I who do that for physical components of software, and we don't have it at the systems level, nor at the supporting infrastructure level of what goes into it for dependencies like visual and our own internal tools. And that is a scope beyond what Andrew should be responsible for, just as a point of order. So that would be part of what he needs to be aware of and needs to be respectful of, but is not required to enforce or implement that particular configuration management documentation. Okay, so I don't know why I'm showing you that. That doesn't imply anything. In Visual, just by the way, they do have an engineering change process, and the way that works is just the way it should. If you want to change a bill of material, you might want to add a new type of screw to replace another screw. You would literally go into the engineering change notice, describe all that, and then you would show in the bill of material the current engineering master where you're going to take one screw out and put another screw in. So you would change that around, and it's able to capture that delta difference, and then the engineering master that's out there that you're currently using to produce work orders from is still the old one, and then as of a certain date or serial number, you tell it to incorporate that engineering change, and then it will. So literally a week from Tuesday, as you're creating work orders every day from the engineering master, the one starting on Tuesday, the engineering master automatically is going to get changed to that delta difference because the system is going to incorporate that change into the tables of the engineering master so that new work orders from that point forward will now have the new screw. Interesting, huh? And the way it does that is by actually creating another engineering master with a revision on it. So you'd go from 00 perhaps to 01, and then you change the part table, the part master, to point to the 01 engineering master so it knows that as of that moment to start using the other revision of the engineering master to create work orders. And that's deployed by that engineering change control, which is really quite sophisticated. So I digress. Now we're going to go into classes. So we talked about the other thing, whatever the heck that was called, the engineering, the class. I thought we called those classes. Didn't we call those classes A, B, and C? Hold on. Didn't we call those? Yeah. Well, that's silly. Okay, well, they call them class A, B, and C. I could have sworn they had something else here, but they call these class 1 and 2. How about that? Not to be confused with the other classes. But a class 1 change versus a class 2 change. One is interchangeable and the other one is non-interchangeable. And here we go. This is the fundamental deal of revision control. If we look at a bill of material, let's say we have up here the top part number of the thing we're building. It's called integration or a snowplow, whatever you want to do it. And underneath here are additional parts like this. And maybe this one even has something, that's not how you spell part, underneath here and here. So we have a 3-level indented structure. This is going to have a revision. So let's say it's Rev 01, this one's Rev 01, this one's 00, 05, and this one's 06. Okay? So these all rolled up makes the 01. These rolled up makes the 00. Does that make sense? The rules of interchangeability say, how do you change those revisions? If I am changing this part number from a 01 to a 02, what else do I have to change in this structure? Well, you don't have to change anything down here, but going upward, if this may have to change, because if this is changing what part that part is, then essentially that changes that part. But how do you know if you should do that or not? That's the rules of interchangeability. What interchangeability is the manufacturing concept from way back when they made guns, and they had to, each gun was unique in that the machined parts were machined by the same craftsman for the same gun. So if you had a barrel or some kind of pin or something in one gun, most likely it wouldn't work too well in another gun because it would be slightly off in terms of tolerances and so on. It would just not fit quite right. When they started doing things on the assembly line with Ford, they had one person make the pins, one person make the barrels, and then they had to change their quality standards so that these would all fit together, because if you still had artisans doing each one of those, there would be enough variability where they wouldn't quite fit together. However, the fact that you have each part made by one person means there wouldn't be a whole lot of variability within that part. So the only problem they would have is in the tolerances not being tight enough or being too loose, and the overall design, so that any variability between them would end up with a gun that works. So to do that was quite a challenge, and that's really what the assembly line process is all about, with finding a way to introduce a quality standard of reducing variability and acceptable tolerances, so that when you end up with parts feeding into parts, feeding into parts, feeding into parts, the thing works or even fits together. Because at some point you have cumulative tolerances, and if something is a little bit too small and the next one's a little bit too small and the next one's a little bit too small, you end up with a lot too small, and it's not going to work. So that's what interchangeability is, and the same thing applies here. How does it apply to software? It applies wonderfully to software. Non-interchangeable, get to that here in a second, non-interchangeable is when a part is to be changed and the changed part will not physically fit or function as a replacement for the unchanged part in all applications of its previous revisions, and all unchanged parts will not physically fit or function as a replacement for the changed part. The parts are considered non-interchangeable. Now, I'm not going to read that again. A non-interchangeable part requires a new part number. Okay, so if we have the 7-inch pin being replaced by a 6.5-inch pin, and if it still has the same form, fit, and function, and works the same in every revision previously produced, then only the pin needs to be changed in terms of its part number, or its, I'm sorry, this is talking about part numbers. I kind of confused there. Then only that pin will have to have a new part number. Everything infected by that can just be a revision change, because remember, a revision change doesn't change what it is that we're producing. If I go from 01 to 02, it doesn't mean that I'm producing something entirely different here. If this is the component that does job costing, it's not all of a sudden like this is the component that washes your windows. It still does job costing. It's just been revised to do it better, or to do it in a non-broken way. But it's still the same thing. However, if the change that we're introduced changes it enough to where the form, fit, or function of it to the level above has changed, where it has significant, where it can no longer be, let me rephrase that. As long as this guy doesn't care if you put the 01 or the 02 into it, then it is strictly a revision change. If you have to care about it, then the part number has to change, because it's actually changed its form, fit, or function. If it's may not have gone so far as going from job costing to window washing, but if it's gone from job costing to a different style of job costing, where we have the old versus the new, and they are significantly different, to this guy's perspective, then this guy has to change part numbers. All right, kind of muddled that one up a little bit, but let's see if we can't get this clearer. That's the class 1, or the non-interchangeable change. The only exception is if this thing has never shipped and a customer has never seen it, then we can sneak by as doing this as a class B engineering or a pre-production release, which means we can just change the rev on that, and that's kind of the shortcut, because no one could be the wiser that never went out the door. The key there is, if this was actual inventory, we have to rework all the inventory or destroy it right then and there, so we don't have ambiguous inventory. But for us, that means you can't have that thing in source safe and in our checked out files or somewhere else as both things with the same identification. So that is a big shortcut, because you're not going to want to, just because we've changed something, and almost everything, by the way, is a non-interchangeable change. We don't want to keep bumping and changing part numbers just because we're perfecting something in-house. That's going to be a real pain, even though we're on that home stretch of testing something with a customer. And so this shortcut is of enormous benefit, but you can't have something ambiguous come out of it. You got to destroy the old one. And this is a better example of this would be, I know I'm kind of digressing into this, but this is the gotchas of all this change control. A better example there would be, we ship something off to Market Trust Built. He finds the problem with it, and he changes his stored procedure because we had a table spelled wrong, just something that simple. And he said, I'll just change it and get it to work, which kind of stands to reason. He's not going to change that revision. If his is still -07, ours is still -07, we can't have that discrepancy. Either he needs to change his to -08 to immediately change our table name so that our 07 matches his 07. Now that is as far as you can push the rules of interchangeability and configuration management, because fundamentally that's wrong. It's already gone in the customer's hands, therefore we should formally release it. But this is the one pliable area that says this stuff's going to happen a lot. So let's make the shortcut to make life easy for everybody. And notice it's still at pre-release. It's not at an A or B or something. So that's, we can do those sorts of things because we're not that formal yet. But we have to make sure that we make that change immediately and not just think we're going to do it someday, because it is going to be a real pain to have two different things with the -707 rev on it. Whew. Okay, interchangeable changes, class 2 interchangeable changes. This one here is when two or more parts possess such functional and physical characteristics as to be equivalent in performance and durability and capable of being exchanged one for the other without alteration of the parts themselves or of adjoining parts except for adjustment, and without selection for fit or performance, the parts are interchangeable. Whew. An interchangeable change only requires a revision letter update to the document. So, is that pretty clear? I can make it much simpler for you. There's an old rule in engineering that says form, fit, or function. So if it looks different, if it fits different, or if it functions different, then it is different. If any one of these are. If it doesn't have any difference in form, fit, or function, then it is innocuous and it is an interchangeable change. So just remember the 3 F's: form, fit, or function. Changing the comments on a stored procedure to have better documentation does not change the form, fit, or function of that stored procedure, so you don't have to bump the revision on it. That kind of thing, all right? Fixing a bug does not change the form, fit, or function. Now, it becomes a discussion of where do the revisions take place. That's kind of where I was heading back on this thing. I got a little digressed. Do you only do it here, or do you keep going up? Well, you may be thinking you only do it at the level you're operating at. If this is the item we're changing, then we just change the revision there or change the part number, depending on rules of interchangeability. But if we're shipping this guy up here, if we want to be able to know what we have, the 01 can't be ambiguous if it had the 01 or the 02 here if this thing matters. Because if this has one set of functionality and this has another set of functionality that goes up to here, then essentially we should have a part 01 and a part 02 up here, or even two different part numbers, because they are getting something that has different form, fit, or function. So the rules are, I can cut to the chase on this one too, of going up the line is you continue traversing the line. You use the rules of interchangeability on the line of the bill of material to determine if you're going to bump the revision or change the part number, form, fit, or function. If you change form, fit, or function, you give it a new part number. If you don't, you just bump the rev. And now you start going up the ladder until you get to the top. For each level you go up, you answer the same question. Has the incorporation of this item now changed its form, fit, or function? If it has, then it needs a new part number. If not, it needs to have a revision change. And you keep going to the top, which means you will always have a revision change at minimum all the way up the ladder. So if this thing is 9 levels deep, you're going to have at least 9 revision changes, possibly 9 part number changes. Yuck. So fortunately for us, this isn't terribly deep, but that does say, going back to my point that we don't have an overall system type number for a trust-built integration, for example, although we used to, then that number or that revision would be changing every time we change something down below, unless it's something that is innocuous, like a comment change or something of that nature. And there is another exception in this wonderful world of configuration management to handle that. So we have class 1, class 2, interchangeable, non-interchangeable, and then we have the record-only change, which I think is a class 3, but who knows what the hell they call it. That is a record-only change is made to correct obvious non-configuration affecting errors in the document, on the document, or a tab to the document. A tab is like a, when they do blueprints, they have tabs to show all the subpages, so it's tabulated is what they call it, tabulated drawings. But it must not fit form, fit, or function. There's the 3 words. Only requires a revision letter update to the document itself. So if I were to just change my comments on this part down here, stored procedure maybe that Andrew did, and he, or I did it, and he wants to go in there and actually have a comprehensible comment, paragraph up there describing what's going on, he would still have to bump the rev. Okay? But he's not required to apply rules of interchangeability, so he doesn't have to change, even consider changing the part number, nor does he have to climb the ladder. It just changes the rev of the document. And there's the wrinkle, because I don't know if that's necessarily a document. That is the component. But I think for Agile purposes, we are self-documenting in the executable plane, which means that is, in a sense, a document. That is going to be an interesting animal, because we don't want that to get the best of us, but it's still going to have to go in the manifest, because the manifest is going to show you all that's required to go in there. And it would just make sense that that's would get bumped up like that in that manifest. But it does not, like I say, change the overall structure. So that is a little bit of a weird animal, because you'd have 2 manifests essentially. But the point is innocuous, so we kind of let that slide. Okay, there we go. Now, I think that's the bulk of what I'm trying to cover, and we're going to just briefly cover the other areas of configuration management just to get that familiarity there, and then we're going to wrap up the session.